Well, hello everyone from the McLaughlin bunker at the top of the Liberty Tower over here in Philadelphia. Kind of just kidding. My name is Ian McLaughlin and I have a PhD in neuroscience. And with me are the girls somewhere nearby, and you may hear some yelps and giggles from the mini McLaughlin in the background. And we're working on teaching her colors right now, so hopefully you'll hear her naming a few of them while we chat. Well, I don't know about you, but things have gotten fairly surreal around these parts. I went on the great grocery run of early March a few days ago, and I was happy to see quite a few people were wearing masks, even before guidance came out from the federal government to put something over your mouth when you go out in public. So that was encouraging. And really quick, before I get into the article I found interesting for today, I thought it might be worth discussing the subtler features of what wearing a mask really means. And so for most Americans, I think the intuitive perception of someone wearing a mask is that they're trying to protect themselves from infection by other people. And to some extent that is true, but the reality is that they're much more effective at preventing the mask wearer from spreading whatever respiratory pathogens they might be carrying. So in other words, wearing a mask is primarily like a social courtesy rather than a selfish act. And particularly among younger people, it seems to be surprisingly common that people can still experience extremely mild or even no symptoms whatsoever and still be able to transmit the novel coronavirus, which causes COVID-19, without even knowing it. And so, it's not like someone needs to have some kind of like respiratory inflammation to need to cough. Sometimes something just gets caught in your throat, and sometimes you just need to clear your throat. And you may be completely confident that you don't even feel the subtlest of symptoms. And you're just voluntarily coughing to clear your throat just a little bit. You may have been exposed to someone infected with the novel coronavirus days before and are unwittingly expelling a bunch of viral particles. Okay, and so something else that's come up recently in my personal conversations with folks who are trying to understand the justifications and explanations for social distancing is why 6 feet? Why not 5 or 10 feet? And it's really a very reasonable question. And frankly, I didn't have a perfect answer for them apart from something I've discussed before, which is 6 feet gives sufficient distance so that there's enough time for droplets that contain or could contain viral particles that someone shoots out of their mouth and their nose when they cough or sneeze to have enough time for gravity to literally draw them down to the ground before they make contact with someone else's face. And that's largely true. But a recent article came out in JAMA Insights, which is basically a journal that's devoted to like quick publications to convey a specific finding. And so in this case, a scientist in the fluid dynamics of disease transmission lab at MIT, Massachusetts Institute of Technology, took a more methodical approach to really measuring how far a sneeze really travels. And I know that probably sounds like a little silly, measuring how far a sneeze travels, but perhaps the past few weeks might have lent a bit more relevance to understanding how precisely pathogens, and particularly respiratory pathogens, travel. And so there's been an interest in understanding how respiratory pathogens travel and for a while, like the assessment of how tuberculosis spread was a motivation to characterize what happens when a person coughs or sneezes. So William F. Wells in the 1930s described two primary things that come out of your face when you do either. There are large and small droplets. Large droplets would inevitably fall towards surfaces more rapidly just because they're bigger. And, if there's something like a doorknob or a keyboard or, like a steering wheel or a table or whatever, any pathogens in those droplets would then settle on that surface, just waiting for an unwitting passerby to touch them and then rub their face. Small droplets, however, would evaporate much more quickly while still in the air, which then could enable viral particles that are capable of remaining stable. They could then settle on objects that are much further away. Again, that was in the 1930s, and that whole model, a dual model, led to a kind of dual theory of how viruses can be expelled from a person's face when they cough or sneeze. And so subsequently, strategies to combat the spread of these kinds of pathogens were focused on targeting the viral particles that were transmitted either via those large or those small droplets. And this is the case for the World Health Organization, the WHO, and the CDC, the Centers for Disease Control and Prevention here in the United States. And we basically rely on a similar kind of dual model to distinguish between the transmission of viruses and droplets, those in larger droplets, or in aerosols, those which would be the smaller droplets that evaporate more quickly. So this article by Dr. Lydia Buriba at MIT suggests that these approaches may be a little bit too reductionist, and that there's more of a spectrum of droplet sizes of the stuff that composes what comes out of our faces when we cough or sneeze. And she was, unsurprisingly, principally motivated by the rapid spread of COVID-19. And she gets into some of the physics of what those expulsions are composed of. But what kind of sticks out is that she discusses kind of like an interaction between the liquid and the gas that interacts with each other when someone coughs or sneezes, and that enables pathogen-carrying droplets to move much farther forward than if it was just exclusively liquid, just exclusively, large droplets or small droplets. And so her article includes some pretty impressive videos that are super slow motion, and I think it's freely available. I think this paper, and it's not behind a paywall. But here are some cool snippets from the videos. So first up we have two images taken from like a super smooth and slow motion video of someone sneezing, revealing that a lot more is coming out of your nose and your mouth than you probably think. And just with these two pictures, you can sort of see that there are large droplets. Sorry, the baby is we're all becoming accustomed to being in a small area, I think. But anyway, so just with these two pictures, you can sort of see that there are large droplets that are sort of intermingling with the much smaller ones that basically just look kind of like a gas, particularly in the picture up top. And in these images, you can see that both of these two things pretty easily travel about 2 to 4 feet. Okay, but what I think was probably the most important part of this short article was the tracking of these expulsions over much longer distances. And so this series of images kind of proves that point. So you're seeing 4 still images taken from another different slow motion video of a sneeze that seems to travel about 23 to 26 feet. So the scientist gets a bit into the details of how the physical components of the sneeze change as it travels, but you can sort of see that, as discussed in the early 20th century, the larger droplets drop off first, right? And then there is a sort of more gaseous component that travels pretty damn far. And so, troubling perhaps because, the broad guidance for social distancing is staying a minimum of 6 feet away from one another. So basically, the point here is that components of your coughs or sneezes travel quite a bit farther than we might have anticipated. And so a few weeks or so ago, we saw evidence that the novel coronavirus, SARS-CoV-2, or coronavirus 2, some folks are calling it, seem to be capable of staying viable for a bit longer on various surfaces. And I talked about some of the specific durations of how long the viral particles can stay viable on different materials like cardboard, plastic, stainless steel, about 2 weeks ago or so on this channel. But on top of that, there was also a report out of China that suggested that viral particles could be detectable in the ventilation systems in hospital rooms of patients diagnosed with COVID-19 in the ventilation systems. Okay, so Bariba suggests that these characterizations of expulsions ought to cause WHO, the World Health Organization, and the CDC guidance on strategies to prevent infection, particularly among healthcare workers, as the prospect of novel coronavirus spreading more easily via coughs and sneezes than initially expected. That may render that the typical sort of respiratory protective equipment, the N95 masks that we've heard so much about, that have been in rather short supply, we might need to augment how, or at least alter how how healthcare workers are guided to manage a potentially much farther distance of this virus being able to spread. Okay, so that wasn't the main article I wanted to discuss today. That was just kind of a cool article. I don't think I've ever seen. You can see on the bottom image there, how far that's traveling. It's almost 26 feet. Wow. Okay, so but on to the main article I wanted to discuss. So when the U.S. first started really taking the prospect of this thing spreading within the country seriously, we were still sort of operating on a bare minimum of known characteristics of the symptoms that the infection with the virus causes, right? And so the main symptoms that we read about were things like a heavy, though unproductive, cough, significant fatigue and breathlessness, and a pretty significant fever. Those were the pretty consistent symptoms that were typically discussed. And so, but that was pretty much it, right? But as the virus began spreading in Italy, we started hearing about the possibility that patients may also be exhibiting general confusion as a potential symptom as well. And more recently, confusion has started to be a potentially consistent symptom to monitor. So it was also reported somewhat recently that there seems to be the possibility that anosmia, or the loss of the ability to smell and sometimes also taste, may also be associated with COVID-19. So if one were to speculate what might be causing things like increased confusion or disrupted sensory system like olfaction, one potential explanation might be that the virus somehow disrupts nervous system function, and particularly central nervous system function. And so there have been some reports of symptoms among patients that do seem to corroborate just such an explanation, that the CNS might be involved. But before we get too deep into this, it's worth noting that the vast majority of COVID-19 patients seem to exhibit zero neurological symptoms whatsoever. So we are, regardless of how much evidence there is, we are talking about a minority of people who become infected with the novel coronavirus who then also exhibit these neurological symptoms. So with that caveat in mind, so physicians in Wuhan, where we're pretty confident that the virus first began to spread in China, reported that other coronaviruses were not necessarily restricted to the respiratory tract and potentially also penetrated into the central nervous system. So both of these coronaviruses, that coronavirus I'm talking about, or that they were characterizing, was the one that caused the SARS outbreak in the early 2000s, as well as this novel coronavirus that causes COVID-19. They're both principally conceived as being respiratory illnesses that infect respiratory cells. But there was some evidence out of Wuhan, physicians in Wuhan were just noticing that, at least with that earlier coronavirus, there was some evidence that it affected the central nervous system. And so, you know, the prospect of the virus gaining entry to other parts of the body would be like critically important. And you know, there's even been a hospital in Italy that's set up a distinct unit in the hospital that's devoted to caring for COVID-19 patients who are experiencing neurological symptoms. So they've seen it enough that they thought it was worth it to set up an entire unit. And this emerges from reports of symptoms like strokes, seizures, and then symptoms associated with encephalitis. And encephalitis is just a general term that basically just means like broad inflammation of the brain. And it can be brought about by both infection by a pathogen like a virus or bacterium, or like an allergic reaction. Right? So it's just inflammation. And so in addition to reports of these kinds of symptoms in Italy, there have also been reports of similar symptoms in the United States. So for example, there was a report of a man in his 70s who had a fever but no other obvious symptoms of COVID-19, no significant cough and so on. And this is when he went into a hospital in Florida, I think Boca Raton. The next day, though, after he went to the hospital, he had a significant spike in his fever and then went back to the hospital. And he also had shortness of breath, and he was also clearly quite confused, and he was unable to tell doctors even what his name was. And he also seemed to exhibit aphasia, which is just a disrupted ability to speak. And then there's another case in Detroit, in Michigan, where a woman in her late 50s had a headache and also seemed to exhibit confusion. And so she was diagnosed with COVID-19, and she could tell physicians what her name was, but that was about it. And as time went on, she became progressively less responsive. And so they did some brain imaging, and the imaging suggested that she had swelling and inflammation in different regions of her brain, and also potentially some neuronal cell death. And so there have been reports of patients who visit the hospital due to confusion or cognitive symptoms, but none of the typical COVID-19 symptoms, like, again, fever or cough. But they end up testing positive for COVID-19. So some physicians in Germany, in France, in Austria, and in Holland, in addition to Italy and the United States, have also reported some neurological symptoms among some patients with COVID-19. And that includes in people who are under 60 years old, importantly. And so Dr. Robert Stevens, a neurologist at Johns Hopkins Med School, great medical school, who's been working on tracking specifically the neurological symptoms of COVID-19, he said, quote, "It could be as simple as low levels of oxygen in the bloodstream, which can have a significant impact on the function of the brain and lead to states of confusion and lethargy." And he also said that we're still in the early days of this and we really don't know for sure. So basically it's just saying it could be the case that these patients are starved for oxygen and that will have sort of inevitable consequences for the brain depending upon how severe that deprivation is. Dr. Paul Nee, an infectious disease specialist at the Danbury Hospital in Connecticut, he noted that he's seen 4 elderly patients who had encephalopathy but no other symptoms, who ended up testing positive for the novel coronavirus. And so 2 of those elderly folks they did end up developing a low-grade fever and did require oxygen, but the other 2 did not. And so Dr. Nee said, quote, "The striking thing is we have not seen any real respiratory illness in these patients. They have continued to test positive and cannot be discharged even though they're not really ill." And then, so a study was conducted this past February in China suggested that it was specifically the sickest patients who tended to exhibit neurological symptoms, things like dizziness and impaired consciousness or stroke. And that study suggested that somewhere around 15% of patients with severe illness, so these are among people who are already severely ill, they exhibited some change in mental status compared to far fewer who only exhibited moderate illness. And then a separate study was published in March in the BMJ, noted that of 113 patients from Wuhan who ended up dying from COVID-19, 22% exhibited disrupted consciousness from severe sleepiness called somnolence. I always say somnolence, or even coma. And that group, that 22%, was compared to only 1% of a different group of patients who simply recovered from the infection. So that, it was those data points that led them to speculate that it was only the most severely infected patients that would exhibit these cognitive symptoms. And so these neurological symptoms still remain quite rare. And despite that, even in the United States, the CDC recommends including new confusion or inability to rouse among the symptoms to monitor for people who may have been infected with the virus. So it's sort of becoming a more widely appreciated potential symptom of COVID-19. And so there's a quote from Dr. Jennifer Frontera, a neurologist at New York University's medical school, once again, great medical school, that I really liked about the seizures, because she addresses what I think is a super common misconception about seizures. So she says seizures are not always big things where people fall down and are shaking on the ground. Some could be just veering off, not paying attention, making repetitive or non-purposeful movements, or just mental status changes where people are just not themselves. All of those things can be indicative of a seizure. And then she later says, quote, "You don't feel your best when you have a fever, but you should be able to interact normally. You should be able to answer questions and converse in a normal fashion. I don't want everyone calling 911 because they're overly concerned. We just don't have the capacity. But if someone is really out of it, they probably need medical attention." So it's worth noting that New York City is experiencing the most severe wave of COVID-19 in the country. And many medical centers throughout the United States are not experiencing a saturation of their emergency rooms or ICUs yet. So the health commissioner here in Philly has noted that here, we still haven't reached that point, right, where medical centers are becoming saturated. But several models of the progression of this disease in Philly specifically don't anticipate that we'll reach the peak number of people requiring hospitalization for several weeks. So we're just not quite there yet. And it's been widely discussed in the news at this point, but different parts of the United States and different parts of the world will experience their own waves of the virus rapidly spreading throughout the population, determined largely by things like, how frequently people travel through the areas, how densely populated the areas, how close together people tend to be, and more recently, my daughter is very supportive of social distancing. And more recently, one of the other main factors that will determine this, the timing of the wave of COVID-19 throughout the rest of the country, is how stringently residents have been practicing social or physical distancing. And so, all of these are super preliminary data. And, I've not seen a very compelling explanation for why it might be that this novel coronavirus might cause such disparate symptoms in people. It wouldn't be surprising if some people developed some neurological symptoms given how many people have already been infected with the virus. But the reports of people exhibiting neurological symptoms in the absence of other symptoms, including the absence of respiratory symptoms like coughing, that's intriguing and surprising given what we know about coronaviruses in general. And so, by the way, this virus is very widespread at this point. And so, according to the Johns Hopkins University COVID-19 tracker that I've been using to keep track of the spread of this virus, there's well over 1 million confirmed cases in the world. And, keep in mind, that's confirmed cases. And so within the United States, there are confirmed cases in all 50 states and other parts of the country, which you can see a little close-up view there. So, if you think that your area might be spared from having cases of this virus because it's like less dense than a place like New York City, you're wrong. Rather, New York City was hit first because it was so dense, but it's more just a matter of time. And so, there's some really interesting preliminary research that might help to explain why it might be that this novel coronavirus might be able to infect cells well beyond the respiratory tract. And in particular, some of the virology and molecular biology that identifies like the specific proteins with which components of the virus have to interact to infect cells. But, that story will undoubtedly be told more comprehensively in the not too distant future. But for now, the evidence I've seen hones in on the virus's ability to interact with an enzyme that its cousin, that earlier coronavirus that caused the SARS outbreak in the early 2000s, was unable to interact with. So it's an enzyme called furin, which is found in many cells throughout the body. And so in other words, it's theoretically possible that viral particles in some cases are able to escape the respiratory system and then potentially interact with cells in other tissues and other parts of the body. That's just one of the avenues of research that's emerged that, in these early days, that's based on comparisons of this novel coronavirus, again, SARS-CoV-2 or coronavirus 2, to the coronavirus that caused that earlier SARS outbreak. And so, we're just going to have to wait and see if this proves to be the explanation for why we see such a variety of symptoms in people who are infected. So there's another story that I found kind of interesting into evaluating the potential role played by blood types, or specifically a person's A, B, or O blood type. And so this is research based largely on statistics of the early groups of people who were infected with the virus in China. And that research is really interesting, and there is definitely some precedent for a virus interacting with people differently depending upon their ABO blood type. So like the norovirus, for example, it seems it is capable of doing that, interacts with people differently depending on their blood type. And so it's still kind of early days for this line of research into this novel coronavirus. But, it's an interesting story. There's got to be some reason that we see such a variety of symptoms of COVID-2 or COVID-19, and particularly these neurological symptoms in people who aren't exhibiting respiratory symptoms. And, some of these stories that I just discussed may be the explanation. There may be a combination of explanations. So we'll just have to keep our eyes peeled. But all of this to say that, if you're not treating this like a genuine threat to you and the people you love, either because you're young or you don't live in a dense city, it's time to start taking this seriously. My daughter is. Okay, so that's what I have for you today. Happy to chat about this in greater depth. But let's go ahead and start the live half. I'll spare you my daughter's theories on how this is working. Hello, everyone. My name's Ian McLaughlin. I have a PhD in neuroscience. And I just, on YouTube, you can find my YouTube channel by, youtube.com/anthropoid, or you can just type in, anthropoid brain, something like that, and you'll get me. But I just talked about some really cool recent research. One was a paper a very short paper, and that basically measured how far a person's sneeze or cough really travels, and the results may surprise you. And then there was another report, or there have been reports of potential neurological symptoms of COVID-19 that really haven't been widely appreciated, or hadn't been widely appreciated, particularly early on in our understanding of COVID-19 that's caused by this novel coronavirus. So you can check that out, youtube.com/anthropoid, or just search for anthropoid brain. Of course, I forgot. I never don't forget. It's much easier to see your comments this way. Hey, what's up, Othman? Good to see you, man. How are things on your side of the planet? All right. Oh, thank you for the retweet. I appreciate that. Hey, Michelle. Good to see you. Hello, dear. Greetings from Moscow. Greetings from Philadelphia, in Pennsylvania, in the United States. Hello, Chris. Thanks for joining. Does smoking a lot of marijuana make you dumb? It's a good question. Actually, so I'm, of course, happy to get into that. But there are some really interesting data suggesting that smoking cigarettes, we know it's bad for the lungs, cigarettes, not necessarily cannabis. But specifically, it seems to be a significant risk factor beyond that, not just because like the lungs are a little bit more vulnerable in general, but because smoking actually upregulates the specific protein, the specific receptor with which the novel coronavirus needs to interact to infect you. So basically, it's like your lungs have more satellite dishes available for the novel coronavirus to splash into. All right. Does smoking marijuana make you dumb? Well, it really depends on how you want to define dumb. So, if you're talking about it, yes, it impairs, cognitive faculties like short-term memory, particularly, while under the influence, right? There's some evidence that over the long term, people who smoke a lot of pot, there are specific anatomical changes that can be detected. The question remains as to whether or not those changes are permanent. Most of the evidence suggests they're not permanent. However, I think it's worth noting that one of the most widely consumed drugs in the world, in the universe, I suppose, alcohol has at least as severe consequences for cognition and mental health, but almost certainly more severe than cannabis. So I wouldn't... Hi, potatoes. She's become so much more vocal. I have a daughter. She's over there. And she shared her thoughts about the novel coronavirus and neurological symptoms on the YouTube as well. She's learned potato. Hi. Potato. She likes potatoes. Who doesn't? So the short answer is yes, but all drugs impair your judgment, except nicotine. Nicotine has an interesting effect specifically on cognition. Has sort of very mild performance-enhancing effects. But during withdrawal, you have a marked deficit in cognition and focus specifically. So yes, when I have your knowledge to pull more chicks, you would be surprised. I mean, I'm married now, but you'd be surprised. Yeah, neuroscience is kind of like a handy conversation topic. Two studies of interest: COVID-19. COVID-19 attacks the nervous system, brain, attacks red blood cell function. So, Winston, I mean, we're very much so on the same wavelength. The blood type data is not really, I wouldn't call that like formal, scientifically, scrupulously collected data. It's really more broad statistics. Doesn't mean that it's not true. In fact, there's definitely a precedent. Let me make sure everybody's on the same page that Winston and I are on. So there was early evidence coming out of China that there seems to be a role played by a person's ABO blood type, type A blood, type B blood, type AB, type O, that seem to distinguish the severity and the likelihood, the susceptibility that people had to this novel coronavirus. Some people with certain blood groups or blood types were more likely to catch the virus and were more likely to exhibit severe reactions. But that really has not been demonstrated. But there is a sort of virus immunology precedence for viruses interacting with people in different ways depending upon their blood type, most notably the norovirus, which is sort of like, it's sort of notorious for being spread on cruise ships. But basically it's like it makes your stomach really uncomfortable and the other end rather uncomfortable as well. So it wouldn't be like, oh my gosh, this is such a strange finding. But I haven't seen studies that really adequately demonstrate that for us to be like, for sure, definitely. The other one was the neurological reports of neurological symptoms. That's what I spent the majority of my time talking about on the YouTube. Again, it's youtube.com/anthropoid. Again, those are not like rigorously conducted, peer-reviewed studies of the neurological symptoms of COVID-19. Rather, these are like case reports, but there are a lot of them. And it's not like only one part of the world has noticed them. Even there's a hospital in Italy, I believe, that devoted an entire unit within the hospital to people who have COVID-19 who are exhibiting neurological symptoms. And so I talked about, and actually in the United States, now the CDC, the Centers for Disease Control and Prevention, recommend monitoring for unusual confusion, or just sort of like altered consciousness, essentially, as one of the symptoms to monitor. I know the Commissioner of Health in Philadelphia has also made that recommendation. In addition to the respiratory symptoms, coughing, unproductive cough in particular, shortness of breath, and things like that, and fever, of course. But once again, that has not been a study. It would take a long time for that study to be adequately performed. There are enough data to suggest there might be something going on there. And so, if you want a deeper dive into that, check out the youtube.com/anthropoid, or just anthropoid brain in the search bar. Okay, well, where's the cure? Is hydrochloroquine the cure for the coronavirus? Great question. So, I should say thank you so much, as always, for the super heart, Sherry. I really appreciate it. Really appreciate the support, because my microphone stand is broken. I don't know if you can see that. Probably not. Hopefully not. So I'm not a physician. I'm a scientist, PhD in neuroscience. But like I think pretty much everybody in the biomedical community, my attention has been, disproportionately devoted to paying attention to this stuff. And so hydrochloroquine, much like chloroquine, is, it seems to be effective in treating some people with the virus, specifically in but there's also evidence that it's not particularly effective. And so it is really a suboptimal treatment. I think everybody is on the same page within the biomedical community that, it's good that we have it, particularly for very severe cases, but it's really not specific. It's certainly not specific for the coronavirus, coronavirus 2, as some people are calling it, SARS-CoV-2, or CoV-2. Really what hydrochloroquine is doing is it's inhibiting your immunological reaction, immune system reaction, to limit the damage that reaction to the pathogen causes. There are other potential treatments out there that would be far more effective if they prove to be effective. Of course, a vaccine would be ideal, but it's going to be a while until we get there. A small molecule drug, just a medication that doesn't require vaccination, would be really beneficial and is probably more likely to come out more rapidly than a vaccine would. But we still don't know if any of them work. Like remdesivir is one of the candidates that has gotten some attention. And so hydrochloroquine, it's used to treat malaria. It's used to treat lupus, and in some cases, severe arthritis. But there are some significant side effects of hydrochloroquine, or hydroxychloroquine, which is, there can be like damage to your visual system, a bunch, it's just not the kind of thing that you would want to take, particularly if you're not even at risk for it. So like the notion that people are running out and getting that drug just in case is not prudent. I mean, it is far better to spend your resources, hardening your ability to shelter in place or social distance, physical distance. Okay. You explain it in a lighthearted way. That's what I try, which is why it's used primarily for lupus. Indeed. Well, it's not only for lupus, but, it's like, imagine, think of it as like the military, right? The immune system does kind of function similarly to the military in some ways, but like, you could, if you're trying to disable a group of soldiers that are in vehicles, you could just bomb the whole area, right? That would sort of be like hydroxychloroquine. Or you could go in and, disable all of their, motor capabilities to prevent them from moving. That would be a little bit more targeted, and you wouldn't end up, harming a bunch of, additional people. Or you could go in and specifically take out the enemy combatants, and that would be ideal, right? And so, there are a bunch of different potential treatment prospects that are out there that are really compelling. And, it's good that hydroxychloroquine is available and it is being used as a treatment, but what we really need is something that's more specific to this novel coronavirus. Okay. Antibodies solution seems to be the answer. Yeah, there's also convalescent plasma. That's an interesting candidate that, like, basically the concept there is that, we have the majority of people do recover from COVID-19, right? It's important to acknowledge that. And part of the way that they recover is they develop antibodies against the virus, and then those antibodies attack the virus, and then you have antibody memory for a period of time. We don't know precisely how long for this novel coronavirus, but regardless, if you could go in and extract those antibodies, basically the way it works is like you take blood from somebody who's recovered from COVID-19, and then you just spin it really fast, right? You might have been on the Gravitron if you ever went to like a county fair or whatever. That's essentially the same concept, but way faster. And the blood will essentially like segment into different layers depending upon how dense, how big different things are in the blood. And you can just go in and specifically remove a section of that centrifuge solution that will contain antibody. Potentially you could just infuse that into people who are suffering, and that might be effective. This is like a pretty old school strategy, in fact. But it is something that I've seen a lot of experts in the field emphasize as a potential solution. This dude is on Concerta. No, I'm not, but I do know what Concerta is. Concerta is methylphenidate. What's interesting about Concerta is methylphenidate. So Concerta, folks might be more familiar with Ritalin. What's interesting about Concerta is that rather than developing some kind of altered molecule of methylphenidate, rather they just developed a capsule that enables slower delivery of methylphenidate, right? So it's sort of like an extended release methylphenidate. It's a cool strategy. It's like a physics strategy to medicinal chemistry. This is as opposed to like, Vyvanse, which is amphetamine. Amphetamine and methylphenidate have very similar pharmacology, not the same, but that's why they're both used to treat ADHD. What they did with Vyvanse is they attached an amino acid to the amphetamine molecule that then needs to go through your whole digestive system, essentially, to then cleave that lysine off, to then, liberate the amphetamine molecules to then do their business. And so that way you have a much longer, extended effect. Winston, if you're on Twitter, I would love to connect. Chem Archive, glycoprotein, inhibit heme metabolism. Dude, if you're on Twitter, let's connect. It seems like you're paying close attention to this, and I would appreciate insights you have. Hey, what's up, Frankie Knuckles? Good to see you. Do you think people that got the flu shot are the ones getting COVID? There's no evidence for that. I've never seen any evidence for that. In fact, there's some evidence that in countries that mandate a TB vaccine, that there tends to be a lower frequency of fevers among people who get infected. We don't really know why that is. There's some interesting potential theories. Happy to get into that, but we have a caller. And since everybody's home from school, you never know, we might get a troll. But I eat trolls for breakfast. They're delicious. Their lack of self-confidence just gives me power. Okay, so it sounds like we're connected to B. What's your name and where are you calling from? B Love, are you there? B Love? B Love? B Love? Okay. Sounds like for whatever reason we're not able to connect. Try calling back in. Do you ever have free time? Yeah. Actually, particularly since I'm in the process of trying to find a job. I might have gotten the job, but as is the case in all things, COVID-19 might have molested my ability to pursue this job. It would be so much fun. I hope so. Check your mute. Oh, it's not on mute. This device is never muted. Okay, sounds like we are connected. What's your name and where are you calling from?
Hello?
Hi. Is your name Richard?
Yes, my name is Richard. I'm calling from Los Angeles.
Richard in Los Angeles. What's on your mind?
What happens if you get hit in the head a bunch of times? What happens? Can you get like a tumor or something?
Sure, I'm happy to answer that. So getting hit in the head a bunch of times, that is, a pretty direct way to say it. And, essentially you can have either a concussion, right, where you have traumatic brain injuries. You can have a concussion, which is a rather severe head injury that, generally speaking, induces a momentary loss of consciousness. Depending upon how long a person loses consciousness, that sort of helps to determine the severity of the concussion. And that's a big deal. Concussions, I know when I was in high school playing football, concussions were like, oh, they happen. They're probably not good for you, but like it's all part of growing up, right? Now we know that that's not the case, particularly for adolescents who are at a greater vulnerability of concussions than adults, believe it or not. I ended up having 2 concussions in one football game, believe it or not. So you can have that. But you don't have to have a concussion to have a traumatic brain injury. You can have what are called subconcussive injuries, which is basically like your head is getting jostled around in your skull. So literally what we're talking about is that the brain is bathed in a solution called cerebral spinal fluid in the skull. And so it's sort of like floating there. Not quite, but sort of. And, we evolved to be able to accommodate certain accelerations, certain g-forces, so that our brain doesn't, there's no physical jostling of the brain, but only so much. And after a certain point of acceleration, when you're getting hit, for example, the brain physically bumps up against the skull, causing pressure waves to transfer through the brain. And depending upon the severity of the hit or the magnitude of the hit, that pressure wave can kill neurons, and it can damage the connections between neurons called axons. And so depending upon where in the brain that has occurred, you can have different symptoms. And so you don't even have to have a concussion for symptoms to emerge, particularly over the long term. And so there's a condition that's actually become a little bit contentious recently called chronic traumatic encephalopathy, or CTE, popularized in that movie that was that like Will Smith was playing the physician, I think Benjamin O'Malley, I think was his name, who recognized that particularly among professional football players who again receive recurrent hits to the head, he observed lesions that sort of resembled something that you might see in dementia, and it's a little bit contentious because the evidence for that is not necessarily entirely corroborative. But regardless of whether or not that is an accurate depiction of a clinical progression, consistent recurring injuries to the head, even subconcussive, are known to result in a set of symptoms that we used to call pugilistic dementia, basically because before professional football it was professional boxers, and there have been statistics that pretty definitively demonstrate that the longer somebody has been boxing, the more boxing bouts they've been through, the more likely they are to exhibit these symptoms. Symptoms include things like impulse control problems, aggression, recklessness, memory loss, of course, slurred speech, these types of things that emerge from a kind of sort of like a global breakdown in the communication between different parts of the brain. Why is the sky blue? Hydrogen. Okay. This brain scientist gets his intellect from bear partner DNA. I wish. Brain aneurysm. How do you enforce your arteries? Brain aneurysm is 6 millimeters. Victoria, so I'm not a physician. This is definitely a question to bring up with your physician. From the perspective of a scientist, aneurysms are one of those things that I have a similar feeling to aneurysms as I feel to the prospect of an asteroid hitting the Earth, where it's eventually it's probably going to happen. We have no idea when. And it's not necessarily probably going to happen for everybody. An aneurysm isn't necessarily probably going to happen for everybody, but it can just happen. And there's no really surefire way to predict the risk that somebody might have. Generally speaking, cardiovascular pathologies or high or low blood pressure, these types of things can increase susceptibilities. And there does seem to be a genetic component to it, where if somebody in your family's had an aneurysm, it's more likely that other people in the family will have an aneurysm. But beyond that, there's no obvious, solution to hardening your arteries or your vasculature to stave off an aneurysm. But of course, blood, cardiovascular related abnormalities are associated with aneurysm. But yeah, you're speaking of a specific case, it sounds like, and you should really bring that up with your physician or the person's physician. Who would win between a badger and a goat? I would go goat. Badgers are wily and they're small and they're quick, but goats, they don't, they're kind of like honey badgers. Of course, unless you're talking about a honey badger, in which case, honey badger every time. I'm here, just didn't say anything, I guess. Why did you remove me? Oh, well, because the whole point is that we talk to each other. Hey, what's up, Oleg? Good to see you in here, man. Mew app, by the way, I don't know if he's still in here, but he is the dapperest gentleman on the internet. I think it's safe to say. Certainly in Russia, but I think he could make an argument for outside of Russia as well. All right, because the seaweed. Why did the beach cry? Because the seaweed. All right, let's see. I smoke a lot, but still feel sane. How is my mind going to change in the next 10 years? So when you say like you smoke a lot. It depends on whether or not you're talking about cigarettes, tobacco-containing cigarettes, or cannabis. There are different advantages and disadvantages to both. Broadly speaking, it's very clear that cigarettes are far more dangerous to your health. Particularly due to its effects on your respiratory system, but not only, like also the cardiovascular system is affected by nicotine. But the long-term consequences, cognitively speaking, of nicotine and tobacco are completely different from that of cannabis. There's not a significant deterioration in working memory, in cognitive function among people who smoke. When somebody goes to withdrawal, however, there is a deficit in your ability to focus. That's actually one of, surprisingly, one of the most consistently cited symptoms of withdrawal that smokers cite as their aversion to quitting is that they feel stupid while they're trying to quit. They feel lazy and stupid, which is interesting. Okay, let's see. All right. What does alcohol do to the brain? Great question. So alcohol is a weird drug. Alcohol, ethanol is what we're talking about, is weird because most drugs that I just talked about, for example, cannabis, the cannabinoids in cannabis, THC, CBD, nicotine in tobacco, amphetamine in Adderall, or just amphetamine, methamphetamine, heroin, morphine, all of these drugs exert their psychoactive effects by binding specific receptors in the brain to which, typically speaking, neurotransmitters bind. So, for example, amphetamine is capable of binding dopamine receptors. Dopamine receptors typically bind dopamine. Now, they all also exert other types of effects. For example, amphetamine also causes the increase in release of dopamine. So it just sort of cranks up dopaminergic signaling by different mechanisms. But alcohol doesn't really do that. Alcohol doesn't bind a specific receptor. It interacts with a bunch of different types of receptors, most notably the GABA receptor, serotonin receptors, glutamate receptors, the NMDA receptor specifically, and mu opioid receptors. Again, the receptors to which morphine, oxycodone bind. In fact, if you block mu opioid receptors, if you prevent alcohol from influencing those receptors, people will not drink alcohol. People will not voluntarily drink alcohol, suggesting that there may be a very important role played by the opioid signaling system in the euphoria or the sort of rewarding effects of alcohol, the whole reason that people drink alcohol. Okay, so alcohol just sort of modulates, one of the metaphors that I like to think of is if you could imagine your state of consciousness as the byproduct of a mixer that a DJ would use with different knobs to adjust the volumes on different parts of a song. That's sort of like how, your neurotransmitter systems, the various circuits in your brain regulate consciousness. Those volume knobs are shifting here or there, all of a sudden you get really excited, you learn that you might be promoted, or your crush says that he or she wants to go out with you. One of those knobs goes up. When you take a drug, that drug is artificially inducing that kind of an effect, generally speaking, much more so than any natural stimulus could ever induce. Let's, again, taking cocaine or amphetamine as an example, those drugs specifically are modulating specific receptors. Okay, alcohol sort of modulates all of the knobs a little bit. And then it also affects other things like membrane, the outer coating of neurons. It changes their fluidity. So it has a bunch of different weird effects. In fact, one of the cool effects that I remember studying was there is an interest in understanding why it is that alcohol inebriates you, right? In other words, maybe if you have one beer, one shot, one glass of wine, you don't feel inebriated necessarily, but once you have a couple more, then you lose your balance, your coordination, right? You start slurring your words, stuff like that. One of the reasons, at least, one of the several reasons that alcohol causes you to be sort of dizzy and wobbly is that it actually influences the concentration of the salt water that fills certain little cavities basically right next to your inner ear, called your semicircular canal and your otolith organs. And so, we have obviously the classic five senses, but we also have additional senses that nobody talks about, which are, you are sensitive to acceleration. So if you're moving forward or backward or side to side. You're also sensitive to rotation. So if you're rotating. And the way that both of those things is those fluid-filled sacs in your head, right? And that fluid is salt water, essentially. And alcohol modifies the concentration of that liquid, making those very specific sensory organs less accurate, or just alters signaling, but yeah, less accurate. Pretty cool. So it does a lot of stuff, in other words. What does COVID-19 do to the brain? That's an awesome topic. And in fact, I talked about it to some degree of depth on my YouTube channel, youtube.com/anthropoid. Or you can just do anthropoid brain in the search bar. So the short answer is we don't know. We don't know precisely what COVID-19 or this, COVID-2, SARS-CoV-2, how it influences the brain. However, there is evidence that at least in some patients, there is an occurrence of symptoms that are very clearly neurological, and sometimes even in the absence of the more classic symptoms of COVID-19, like coughing, fever, shortness of breath, exhaustion, things like that. So it's like, so there is some, that's intriguing because, okay, one physician I saw commented, like, we know that COVID-19, one of the reasons that we're so concerned about a shortage of ventilators in the United States is that when people become severely ill with COVID-19, they become less capable of literally absorbing oxygen out of the air. And so you have to pump in oxygen through the lungs using a ventilator. And so, one of the physicians was like, okay, so we know that basically in these patients, one of the central problems that they're facing is that there's a deprivation of oxygen. And we know that a deprivation of oxygen in the brain would cause neurological symptoms, right? That's essentially what a stroke is. However, if that were the case, then you would expect that you would only see those neurological symptoms in patients with severe COVID-19 who are responding very severely to COVID-19. And that's not what we see, or that's not what has been seen in China, in Italy, in Austria, in Holland, in France, and also in the United States. So if you're interested in a deeper dive, and also there's some speculation as to how it is that this might happen, like how it is that a respiratory virus might be able to affect the brain or the central nervous system. Check out the YouTube video. First 15 or so minutes when I go live, I do like a deeper dive into something on YouTube. I also talked about on YouTube. Oh wait, I probably still have the, yeah, okay. I also talked about a study that traced really how far sneezes and coughs can travel, and the results may surprise you. Okay, that was a great topic. Okay, marijuana turns a male feminine, like this individual that talks fast to act smart. I'm not trying to act smart, but I have been told I speak quickly. Also, I don't smoke pot. So, it's a good, attempt there to make me feel bad, but this guy can't even operate a lawnmower, yet he's a brain scientist. Let's scrutinize that concept, right? To be a neuroscientist, you have to know how to operate a lawnmower. It's like, to be a doctor, you must know how to, cook a duck. Like, these are completely unrelated topics. But I will have you know that I mowed my family's lawn when I was a kid. I worked in landscaping, believe it or not, when I was in high school. Worst job ever, particularly in Florida. And I've mowed, well, I won't go there. But so yeah, I actually do know how to use a lawnmower. And I've used both the ridey kind and the push kind and the old school kind that just so in your face, dude. Plastic money. How long do they carry virus for? Awesome topic. JU. Okay, so generally speaking, like the initial concept, and again, I should always just regularly make this this caveat. Not a physician. I'm a scientist. Recently finished my PhD in neuroscience. But like many people in biomedical science, our attention has been disproportionately devoted to COVID-19. So, the initial expectation of SARS-CoV-2, the novel coronavirus that causes COVID-19, was like most respiratory viruses. They really require person-to-person respiratory transmission. That you need to essentially either inhale or touch, active viral particles, and then touch one of the mucosal membranes of the face, the eyes, the nose, or the mouth. And that's true. I mean, that it definitely spreads that way. But there was a paper that came out now a few weeks ago that evaluated the stability of these viral particles on various surfaces, including being aerosolized, including sort of made almost gaseous. And basically what they found was that in these laboratory conditions, the virus remains viable for hours and hours in different durations of time on different surfaces. Like on cardboard, it's a little bit shorter than I think on stainless steel. And actually, I talked about that paper on the YouTube as well, I think 2 weeks ago. So youtube.com/anthropoid, or search anthropoid brain, you'll be able to find it. But basically, it's a pretty long time. It's much longer than I think a lot of people initially appreciated, on the order of many hours to days. And so the good news, however, is that like many viruses that are similar to COVID-2, by the way, my daughter has a toy that she uses in the bathtub. And I was looking at it today and I was like, you know what this looks exactly like? This is basically what the novel coronavirus looks like. It has this sort of circular kind of shape with these little nodules along the outside that are the reason that it's called a coronavirus, because it looks sort of like a crown. But anyways, the nice thing about this novel coronavirus is that it is vulnerable to basically like run-of-the-mill household cleaners, like don't touch it, like bleach, rubbing alcohol, soap, hydrogen peroxide. So the nice thing is that it's not like this virus just lingers for ever and ever. No matter what you do, you can clean them off of surfaces. And so I can tell you what I've been doing. So copper, it stays on copper for a long period of time too. And there are some really unscrupulous people out there trying to sell like copper nasal inserts to try and treat the coronavirus. That is not based on science. But so, I can tell you what I've been doing. So first of all, in our tiny little apartment, about 600 square foot apartment, we have an area of the apartment that is essentially like for decontamination. First of all, the girls essentially never leave the apartment. They not essentially, they never leave the apartment. And then every now and then I go out to get groceries. I've been wearing a mask. Happy to talk about masks if you'd like. I wear clothing that covers me a lot. But then, so when we get in, anything that's coming into the apartment gets cleaned. Clean it with either bleach, disinfecting wipes, and then we also just let it sit there, let those things sit in that decontamination zone for an extended period of time. Particularly, if it's coming from something like Amazon and it's not perishable and you can just, it can sit there and it won't break or melt or whatever. Just let it sit there for a day or 2 days. Then you can be at least a little bit more confident that, you're not just like importing viral particles. I think most biomedical scientists would still emphasize that like the primary mode of transmission remains respiratory, remains breathing in or touching somebody's viral particles that they've expelled from sneezing or coughing. There's also evidence that it may also be able to spread just from breath. I also talked about a recent study that characterized just how far these sneezes and coughs travel on the youtube.com/anthropoid, or search for anthropoid brain. Okay, what type of edibles do you need to take and type of marijuana for insomnia? So, Bell Ronnie, what's interesting about cannabis is that definitely for some people, like cannabis edibles can help them to get to sleep. But what's interesting is that in some people, it actually can do the opposite. Particularly as we get a little bit older, there seems to be a cohort of people that respond with panic attacks and anxiety attacks to cannabis. And there's some really interesting neurobiology that might explain why that is. The short story is that the endogenous cannabinoid receptors actually change developmentally as we get older. And they're present in the amygdala and they change in the amygdala. That might help explain why it is that, people who smoke pot when they were younger, and then they stop smoking pot, and then, later on in life, they're 65 or whatever, and they're like, hey, I want to enjoy some pot, and they smoke it and they have an anxiety attack. It's like, what's the deal? And, of course, tolerance will play a significant role, but also there seems to be a neurobiological explanation for why. All of this to say, edibles and cannabis don't necessarily guarantee, they're not like sedatives necessarily for everybody. There is some anecdotal evidence that CBD can be helpful for some people with sleeplessness. But I would not say that that's reached the threshold of evidence that would indicate that it's good for everybody who's having trouble sleeping. Okay, and we are graced with a call from the illustrious Euromaestro. You can find him in Euro. Euromaestro, what's on your mind? And, where are you calling from? Are you in France?
I am in Paris in lockdown.
Wow. So how's it going over there?
It's going fine. I mean, just like any other place, I guess, that has to deal with mitigation strategies. But hopefully, it'll slow the virus spread and bring the R naught down to a number that's more manageable for our healthcare systems.
Yeah, indeed.
But yeah, actually, I had a specific question for you. I mean, it's a long shot because I don't know if you've read it, but there was a study that I was reading over on RxIV,
Yeah.
and it was an NYIT study about a connection between BCG vaccination policy and morbidity and mortality rates.
Yeah.
And I don't know if you had a chance to read it or yet.
Yeah. So I saw a bit of reporting on it. I haven't read the medRxiv study yet. But basically what Euromaestro is discussing is there is this correlation between countries that mandate essentially a TB vaccine and a lower incidence of fevers among people who catch COVID-19. And so, some of I think the best explanation I've seen is that, like most all viruses, SARS-CoV-2 or the novel coronavirus relies on interacting with a specific set of proteins that are quite densely present in the respiratory system, the ACE2 receptor. But that might not be the only receptor with which it needs to interact. And then it also needs to interact with an enzyme called TMPRSS2, and then potentially also another enzyme called furin. And so it could be the case that while obviously TB is not identical to this novel coronavirus, that once somebody develops antibodies against TB, those antibodies might sufficiently recognize a certain component of SARS-CoV-2 to diminish its ability to invade cells via those mechanisms. It's important to note that we don't know for sure how SARS-CoV-2 enters cells, but given its similarity to the coronavirus that caused SARS, it's probably the case that it's relying on similar entry points. But yeah, that was the best example. That was the best potential explanation, is that there's just enough overlap between the immunity that one develops when they're vaccinated that they're able to mount a more effective immune response more rapidly. Have you seen any more specific explanations?
Yeah, no, I think that explanation is consistent. What's interesting, because I read the report, and so they did kind of take into account like differences that the other differences that might explain this, right? That might not be related to the BCG vaccination. So like different countries, have different degrees of wealth and healthcare systems and stuff like that. But when they try to take that out, you still see a very strong, statistically significant difference in mortality and morbidity. And what's interesting too is that you also see in countries, for instance, that have a universal BCG policy, but enacted it much later.
Right.
They don't have as good as results as the ones that have been doing it for a long time, which is consistent with the idea that, an older population would have already been vaccinated. And so there, like I said, I do want to give a caveat out because it hasn't been peer reviewed yet. But, assuming, let's say that, their methodology is good and stuff, the data, at least on a first view, looks very encouraging.
Yeah, and I mean, it is just statistics, right? I mean,
Yeah.
But it could also just be like an indirect indicator of like, okay, these countries have mandatory vaccination for X, Y, or Z that correlates with other healthcare components that just render the country more, effective in.
That's what I mean. But that's what I'm saying. The study addresses that point, and they did try to specifically isolate that. So like when you look at the charts, for instance, that's what I'm saying. Obviously, they realize that there could be other factors, right?
Right.
So they try. That's why I'm saying like they try to look at things like wealth and how advanced the healthcare systems are and things like that.
Right.
And you can see on the charts, for instance, even in countries which are very poor and have not very well developed systems, but do have a universal BCG policy, you see their death rates are down significantly from countries, for instance, that are very wealthy and have,
Right.
Otherwise, good healthcare systems that don't have a BCG policy. So that's why I said, obviously it's not conclusive.
Yeah.
But it's
an
indication that perhaps there's something in this.
For sure. Yeah. I mean, I guess that, the only reason I was bringing all that up is like, the question is like, should we be, just giving everybody a TB vaccine, or
Oh, no, yeah, no,
right,
obviously
yeah,
it has to be looked into, yeah, of course.
exactly,
But there's
yeah,
a lot of these therapeutics and other indicators that look like, at least, again, we don't have these randomized control studies that in large numbers, but based on the little anecdotal evidence and applications, the preliminary data looks very promising.
yeah, yeah. I mean, the prospect of having a small molecule treatment before the vaccine, I think, is like one of the more encouraging features of our potential response. But yeah. I mean, it's an interesting correlation for sure. Yeah, I'll have to check out the. By the way, just so everybody knows, Euro is referring to a website called MedArchive, MEDRXIV. And so that is a journal, essentially, a website that's run by the Cold Spring Harbor group.
Right.
And basically what it is like, scientists, like we've used it before, scientists will submit their paper to these archives. There's bioarchive, medarchive, phys archive, I think, chem archive. And basically it's like you can see these papers before they go through peer review. So that's what Euro was saying. It's not peer reviewed yet, but there's obviously an interest in getting these data out to as many people as quickly as possible. But it's all open source, so you guys can go read it if you want. And yeah, it's super interesting. Was there anything else on your mind?
Yeah, I'm just going to ask you one thing real quick. I want to drop down so other people can ask questions. But any thoughts about these potential vaccine candidates? And do you think that this might be a good opportunity for like a DNA or an RNA vaccine to be approved? Because there seems to be some promising things there, and it would help with the rapidity and whatnot.
Yeah.
And I'll drop down.
All right. It was a pleasure talking to you, Euro, as always. Best of luck to our friends in Paris and in France. Yeah, so what Euro is referring to, so there are different strategies to develop vaccines, right? And, they range fairly widely, but one of the newer strategies is to just literally develop a vaccine based off of the genetic sequences that we know of, any given pathogen, SARS-CoV-2 included. In fact, one of the companies that has developed that platform is actually just outside of Philadelphia. I know, and the advantage of that would be that you could create a vaccine for a completely novel virus much more rapidly. And so we wouldn't have to necessarily wait for months and months and months. But, we would still have to wait for months. And, as we speak right now, I think the fastest in history, a vaccine has been administered to a test group of people. In fact, one of the people is journaling his experience on Twitter. You can follow. I forgot his name, but I'm sure you can easily find it. And so, one of the interesting things, there's going to be a lot of evaluation and learning that emerges from this pandemic. And one of the things is that, in the United States, we apply a fairly stringently high burden to vaccines, to a lot of medications. And it's funny because at different times, people become frustrated by that level of stringency or by an insufficient stringency. So they become frustrated by how long it takes to prove that a vaccine is effective or that a drug is effective when there is a pandemic that we're dealing with right now. Do we really have to wait for 18 months of validating safety, validating efficacy? Can't we just get it to people right away to prevent death? It's an understandable complaint. And, there's some argument behind that. But then, the flip side is anybody who's talked about vaccines on the internet before knows that there is a very significant risk where if, for whatever reason, a vaccine, this is true for medications as well, is insufficiently scrutinized for potential toxicity, you can harm a lot of people. And particularly once there's a vaccine for COVID-19, for SARS-CoV-2, the virus that causes COVID-19, the concept is that it'll be available worldwide. And so gigantic numbers of people will have it administered. And so that's why, we have this fairly high burden imposed by the FDA to demonstrate that any treatment is both safe and effective. But yeah, and so, I know that the FDA is now engaging in a lot of, I think, totally justifiable streamlining strategies to expedite that process. But even still, even with the abbreviated, waiting periods, it's still going to be months. But yeah, it's super exciting. Yeah, billions of doses, exactly, as Jura said. And, there is already a sort of an endemic skepticism of vaccines, and you don't want to exacerbate that, right? Although it has been encouraging to see that even people who are vehemently opposed to vaccination, they don't seem to be yelling with their sort of typical volume. So that's been encouraging. Okay, on YouTube, glad to see you finally. What have I missed? You're like fresh air in the era of a pandemic. Okay, so Michael Loizu says, are there any blood indicators in early COVID patients that can indicate who's going to be getting mild symptoms and who's going to need intubation? That's an awesome, awesome question. And in fact, a physician scientist named Siddhartha Mukherjee, who's also, I think, like he won a prize that writers get for, he's written some really good books about biomedical science. He wrote an article, I think, in the New Yorker that sums up this whole concern very nicely. And he's also a beautiful writer, so it's just a pleasure to read. But basically, there are a couple different things that may help us to triage more effectively, that may help us to identify people who are at higher risk of needing intubation or needing to go to the ICU, and distinguishing them from people who are the majority of people who don't respond with such a severe illness. And one of the things seems to potentially be dose of virus, like how many viral particles has this person been exposed to, and how many viral particles are they creating in their body. So it might be the case that very high doses of SARS-CoV-2 correlate with more severe reactions. And there's some good evidence to believe that that might be the case, particularly among very young clinicians in China who ended up deteriorating extraordinarily rapidly, despite the fact that they were like in their early 30s. Obviously, clinicians will be exposed to a much higher dose of virus per unit time over a consistent period of time than anybody else, which is why, we need to ensure that they have the personal protective equipment, PPE, that's necessary to mitigate that exposure. But that's one of the things that, Siddhartha Mukherjee is not the only person who has identified that as a potential, determining factor, but that's one thing. Another thing, in terms of you brought up specifically blood indicators, there's some interesting evidence of correlations between a person's specific blood type A, type B, type O, and so on, and vulnerability to getting infection, meaning some may be more likely to get infected by COVID-19, and then also severity of infection, meaning if you have a certain blood type, you may inevitably respond to COVID-19 with greater severity. So that might sound a little crazy, right? Because it's like, that's just your blood type. What is that? That doesn't have to do with your lungs. That doesn't have to do with, your respiratory system in general. I mean, obviously blood has to do with every part of the body, but not directly, not specifically, right? But actually, among other viruses, that is the case. Like a very well-known virus called norovirus, which, a lot of people call it like a stomach virus or whatever. Just it causes vomiting and diarrhea. It's really nasty. That virus does tend to exhibit distinct, levels of severity in people according to blood type. So this concept emerged from some of the early numbers that came out of China in the early days of, actually earlier than the COVID-19 breakout, during the SARS outbreak in the early 2000s, they saw some correlations. But so the issue here is that, and there are some interesting potential explanations for why that might be the case. A person's blood type is basically determined by little markers that exist on the surfaces of blood cells. And they are unique depending upon whether you're type A. So type A blood type have certain proteins that are consistent among people who have type A. Same goes for type B and type O. And that's why, for example, if you're getting a blood transfusion, you have to get a compatible blood type. Otherwise, your immune system will recognize the difference between those types of blood, your blood and this new person's blood, and you'll have a deadly immunological reaction. So this is potentially the case. However, much like we were talking about with this correlation between TB vaccination and lower incidences of severe COVID-19, this is also purely statistical. And as far as I'm aware, it still has not gone through peer review. So, this is just another data point. And, we ought to not consider it as being like, get the person's blood type, and then you'll immediately know, this person's going to recover, fairly with mild symptoms. By the way, another consideration for COVID-19 that I think is worth acknowledging is that even in people who have mild or moderate reactions to COVID-19, there will be a pretty long-lasting, residue of the presence of the virus in the lungs. It's going to take a while to recover, beyond just the point where your immune system has finally killed the virus. I feel like, it's very obvious, and we've seen interviews of people who are younger saying like, I'm young, it's not going to be a big deal, it'll just be a bad flu. It's not necessarily the case. And there's obviously instances of people who are younger than 60, younger than 50, reacting with very severe, instances of COVID-19. And there's also some evidence in the United States of somebody in Michigan, a woman in her 50s, so under 60 years old, who not only exhibited, some of the symptoms of COVID-19, but also some neurological symptoms. So this is, it is not prudent to approach this virus as though it is purely a malady of the elderly. It's just not. There's some evidence now of sequelae too, permanent scarring. Exactly. Yeah. I didn't see, or at least I haven't seen yet, any pathological or evaluations by pathologists of what somebody's lungs look like. That would be very, very difficult to do, right? Certainly in somebody who's still alive. But yeah, I mean that was acknowledged pretty early on in the epidemic in China. All right. What do you think about how mental health clinics closes down? In this case, Denmark due to quarantine. Yeah. So somebody you don't know. That's a great topic. Okay. And so, obviously social distancing or sheltering in place, they sort of mandate that certain interactions just cannot happen the way they normally do. And that affects a lot of different components of our lives. But one of them is definitely psychiatric care, mental health care. And that manifests in multiple ways. In some cases, mental health can be delivered effectively remotely, like over the internet, right? Using, Zoom or Skype or whatever. But in some cases, that may be expected to deteriorate the quality of care. I know in Philadelphia, I've been paying the closest attention to what's going on in Philadelphia just because I'm most familiar with this healthcare system and other reasons. Addiction is a very significant challenge in Philadelphia, in particular in the United States, specifically opioid addiction. Philadelphia, or part of Philadelphia, is among the highest hit with heroin addiction and fentanyl addiction, particularly. And so as a result, a lot of the sort of mental health care for addiction has had to been altered once we all started practicing social distancing. However, there is a physician scientist who is involved in addiction therapy, who has been monitoring remote addiction treatment over the internet, digital, you might call it, addiction treatment. And first of all, attendance has gone way up. And so people are using it, and the early indicators of its efficacy are pretty good. It's reasonably effective. I don't think anybody would say, we should just replace it moving forward with remote treatment. But it is an interesting, thing to pay attention to, right? And so, yeah, I mean, I think it is a challenge, but it is the challenge of, clinicians involved in mental health care to try and come up with alternative mechanisms to treat patients. And I know that's happening in Philly, and so I would assume that's happening elsewhere as well. There is, however, this one kind of concerning element of something like COVID-19, an unprecedented degree of social distancing and so on, which is there are certain psychiatric conditions that sort of lend themselves to being exacerbated by the presence of a pathogen and the necessity of cleaning your hands and, cleaning your face, potentially, particularly OCD, obsessive compulsive disorder. It's like, we all have been instructed to escalate our, hygiene routines, right? But for some folks, it was precisely like hand washing and, literally obsessing or compulsive cleaning of surfaces that was a symptom of their OCD. And so I haven't seen a good answer for, I haven't seen a good, a good solution to that problem. I would imagine that is a pretty substantial challenge for people involved in the care of people who have OCD. How do you say that, like, there's this how do you, convince somebody who is already behaving as though there are constantly,
invisible pathogens threatening their survival when there actually is one now. And how do you navigate that? That must be really challenging. I don't have a good answer for that. But yeah, I mean, it's a challenge for everybody, and that's just one of the challenges. Euro says Philadelphia trying to make up for its response in the 1919 influenza epidemic or pandemic. Yeah, no kidding. Yeah, so Euro is referring to probably one of the most famous public health stories that like everybody learns in public health classes, which is, in 1918 there was a giant outbreak of influenza. It was extremely dangerous, killed millions and millions of people, and and what happened was, there's a comparison that's always made between St. Louis and Philadelphia. The reason that those are chosen is that they took very different public health approaches to confronting the influenza outbreak. In St. Louis, they responded fairly early on with social distancing, a lot of the same kinds of procedures that we're following today. Philadelphia waited, and that turned out to be disastrous. Like hundreds of thousands of people died in Philadelphia. And in fact, interestingly enough, last year, I believe, was the inaugural year where one of the coolest parts of Philadelphia, if anybody ever comes here, go visit the Mutter Museum. It's one of the coolest places in the country, in the world, I would argue, particularly if you're interested in biomedical science. But they sponsored a march down Broad Street. It's like the central main artery of Philadelphia that leads all the way to City Hall. From like the sports stadiums, the link, a march all the way down of people. And it was really cool. They you could sign up, you would be assigned a person that ended up passing away from the influenza epidemic. It was remarkable. Like, I didn't expect, my wife and I were actually coming back into town from visiting, I think, her family or my family, who cares? And we, usually we'll drive down Broad Street, but it was completely blocked off. And we were like, what is going on? There's like so many people out here, and that's what it was. So, sort of foreshadowing of how we would have to respond today. And I do have to say that the Philadelphia municipal government has been pretty good. They everywhere in America could have and should have responded much earlier. Then we wouldn't be confronting hundreds of thousands of confirmed cases in the United States. Hundreds of thousands of confirmed cases. And confirmed meaning those are just people that have been tested. And we know that we were so late on testing in the U.S. And so we know that that is a substantial underrepresentation of the true, accurate numbers of people infected with COVID-19. COVID-19 is now passed it's over 1 million, I think 1,200,000 plus confirmed cases worldwide. I mean, this thing is everywhere now. And again, those are just confirmed cases. So the whole country responded too late, but Philadelphia definitely responded among the earliest of metropolitan areas. And I think that part of the reason, one of the payoffs of that is that our hospital systems, our ICUs, our emergency rooms are not saturated like they are in New York City. It's a different size city, different kinds of businesses, different transit, and so on that comprise the two cities. But we're doing okay for now. And the projection of when the peak. Well, you guys don't need to learn all about Philadelphia so much. I love your streams. I had my first grand mal seizure last month. What are your thoughts on anti-epileptic drugs like Keppra? Sorry to hear that. So for anybody that's not familiar, seizures can present in different ways, different levels of severity. I should always acknowledge I'm not a physician, I'm a scientist. And so I always approach these types of questions from the perspective of a neuroscientist. So what seizures are, for anybody that's not familiar, is essentially like aberrant, irregular, highly frequent, typically, action potential firing or impulses. So that's like the language of neurons, or one of the main languages of neurons is how frequently they fire impulses. When somebody's having a seizure, some part of their brain, and there's different magnitudes or different sizes, literal sizes of seizures, is behaving aberrantly and firing too many impulses, essentially. And depending upon where in the brain, you can get convulsive seizures, you can get non-convulsant, status epilepticus, you can get absent seizures where somebody just sort of zones out. You can have, a bunch of different things. You lose the ability to contract muscles, or drop seizures, what they're often called. And there are other kinds of seizures, by the way, that don't obviously manifest in any way And a surprising proportion of people who have depression and psychiatric conditions end up actually exhibiting non-convulsant status epilepticus. They're having seizures, but it's not obvious, and there's no reason they would have known unless their physician just decided to strap an EEG on and then, oh my gosh, you're having a seizure. So most anti-epileptic drugs are designed to target the mechanisms of neurons that enable them to fire impulses at all, right? So, they might target things like, ion channels, like sodium channels, oftentimes potassium channels, to basically inhibit a neuron's ability to ever get high enough to trigger a seizure, high enough frequency of action potential firing. So generally speaking, because you're not only treating those neurons when they're exhibiting a seizure, you're treating those neurons at all times, generally speaking, you'll have side effects because the behavior of those neurons will be altered in the presence of that drug. And so you can have side effects like sleepiness. You can feel sort of cognitively sluggish. This isn't true for everybody, but it can be a side effect. There are, of course, when somebody goes to the hospital because they're having a seizure, generally speaking, they'll be administered like a benzodiazepine to just, sledgehammer and just stop neurons from firing so many impulses. But yeah, I mean, we're fortunate to live in an era where we actually have medications to treat epilepsy. Epilepsy research is actually one of the oldest biomedical disciplines. It's been around for a long time because obviously people have been having seizures for a long time. And so back in the day, one of the treatments was that, physicians, medicine was not always based on evidence. We didn't always have evidence-based medicine. We used to have eminence-based medicine, where physicians who just had been practicing for, years and years, they were just the best physicians because they had so much experience. But so back in the day, it was like, you are being possessed by a demon. And that may or may not be true. I can't tell you it's not true, but we also know that that's not the whole story. And so, yeah, they're not optimal treatments, but they can be effective treatments. Until, epilepsy research is still a very significant subdiscipline of neuroscience, and still learning a lot about the specific granular mechanisms that enable somebody to have a seizure from the genetic mechanisms. Like, for example, did you inherit the genes that encode for a specific kind of receptor or a specific kind of ion channel that makes you more likely to have a seizure? Is it some combination of life experience and a genetic vulnerability? We also know that some head injuries can induce a seizure. By the way, COVID-19, there are reports of people exhibiting seizures. It's a very, very small minority of patients, but they are there. Seizures who then test positive for COVID-19. And in some cases, they don't even exhibit any of the classic symptoms of COVID-19 or any respiratory illness, like coughing, shortness of breath, an unproductive cough, shortness of breath, and fever. They present with these neurological symptoms. We don't really have answers for why that is the case. We have some interesting potential explanations, but yeah. So, seizure, epilepsy is still being studied, and as we progress, assuming we continue to invest in basic neuroscience research, we'll be able to develop treatments that are much more targeted to treat epilepsy and potentially much more targeted to treat your epilepsy. So yeah. Okay, how long do you think it'll be till a cure? Months, many months. For a vaccine, it'll probably be about, I've seen estimates of 13 months on the more optimistic end to 18 months on the more probably the more realistic end. But then small molecule drugs, it really depends. There are a couple candidates. Probably the most well-known at this point is remdesivir, which is like an antiviral drug. And that's not the only one. There are a couple others. Some of them don't have names. It's just like a series of numbers and letters. But basically, so here's how this works, right? You have a bunch of different pharmaceutical companies. The big ones have a library. Think of the Library of Congress. And instead of each book, they have a specific drug. And, they've had chemists just, synthesize these drugs, but they had no idea what to do with them. They're just sitting there in their library. And then all of a sudden, they don't seem to be effective for any obvious condition. But then all of a sudden you have an epidemic and then a pandemic. And all of a sudden there is this very urgent need to rapidly treat a large number of patients. And so here's what happens. In a large pharmaceutical company, they will, evaluate their library and testing through a system called high throughput testing. Basically, they're in petri dishes. They're seeing if any of these molecules in their library is capable of interfering with the ability of SARS-CoV-2, this novel coronavirus, in interacting with the receptors with which it needs to interact to infect respiratory cells, in particular the ACE2 receptor, and then also interactions with other enzymes like TMPRSS2 or furin. And then, that's just in a petri dish. And so, but they can do that. They can test like tens of thousands of molecules at one time. And then they see a signal. Oftentimes they'll see sort of varying signals, and then they hone in on only the ones that provided some efficacy, some ability to interfere with the virus's ability to bind that receptor. And then they do it again. And then they try and find what specific chemical might be the most effective. So that's going on right now all throughout the country. But we know that there have been antiviral drugs that had been designed for potentially coronaviruses. And they are being evaluated right now. And if any of those prove to be effective, then we can expect a potential treatment in far less time than a vaccine. Because, the potential downsides of vaccines are far more complicated, and you're literally like manipulating a person's immune system. The immune system is a very perilous system. People die from autoimmune diseases all the time, or they suffer because they have an autoimmune disease. And so the last thing you want to do is trigger an immune system reaction that is potentially dangerous. A small molecule drug, so long as it's not toxic to liver cells, kidney cells, the cardiovascular system, as long as you can tolerate it, even if it has, meaningful but not life-threatening side effects, if you can prove that fairly rapidly. And so it would just be a couple of months until, if any of those drugs is effective, until that is available at hospitals. The other nice thing about small molecule drugs is that they're very easy to make. You can make tons of them at a time, and particularly since the president has activated the Defense Production Act, you can just make sure that our entire pharmaceutical industry, one of the biggest industries in the United States, in the world, you're all making this drug now, right? So, a couple months, if any of these drugs are effective. But of course, by then, after a couple months, we will be approaching, depending on where you are in the country, either you will be coming down hopefully, from the peak number of people who are infected, or you may just begin to your ascendance of your peak, depending upon where you are in the country. Hey, what's up, Vorksai? Vorksai, I like that name. Do you think that the coronavirus could cause overactive neuron activity, causing overall exhaustion? So we don't know precisely how it is that this novel coronavirus is interacting with the central nervous system. There are some interesting, unique features of SARS-CoV-2, this novel coronavirus, that seem to enable it to interact with more tissues than its older cousin, coronavirus 1, the one that caused SARS. And so it, but it could be as simple as, because of how effectively it attacks both the upper respiratory system and the lower respiratory system, the lungs deteriorate rapidly enough that you're essentially just getting insufficient oxygen to the brain. And so as a result, that is a classic symptom of having insufficient oxygen to the brain. You get fatigue, or worse. And there are some, I talked about this again on the YouTube, youtube.com/anthropoid, or search anthropoid brain. There are cases reported of people who exhibit, seizures, inflammation upon neuroimaging. I don't know what kind of neuroimaging they did, maybe MRI. They found inflammation in certain parts of the brain, and then also signatures of potential neuronal cell death. And so we don't know if potentially, here are some of the potential explanations. First is a deprivation of oxygen to the brain, right? That's what a stroke is, essentially, is that neurons are not receiving enough blood and therefore oxygen delivery, and so they begin to die. It could be the case that just the lungs are sufficiently insufficient. They've deteriorated enough such that the brain is just not getting the oxygen that it needs worldwide. Globally, I meant. Another could be that in some people, the novel coronavirus interacts with the immune system in such a way as to cause severe enough inflammation that impinges upon the central nervous system. We know that the immune system does influence the central nervous system, not as directly as other parts of the body, but it can influence the central nervous system. So it could just be like an indirect byproduct of the significant inflammatory reaction that people experience when they have COVID-19. Or it could be that somehow the virus is able to piggyback on some kind of cell, maybe it's even blood cells, that are then able to gain entry into the brain and then more, directly attack neurons in the brain. From my perspective, that's the least likely, but we really don't know. It's a great, really interesting question though. It's a really interesting virus. It's really a shame that it's so perilous. It's it's already taken thousands of people. My pleasure. Always happy to talk about those types of injuries. Hey, Abyss is here. Awesome to see you, man. I watched a Japanese researcher video that said yelling or talking loud is almost an equivalent to sneezing. Yeah, Kodak Vox. That's excellent point. So the reason we focus on coughing or sneezing is that is a very rapid and effective way to not only excrete or not only like expunge, expel viral particle, liquid, right? Liquid droplets, but also, essentially everything that's in the respiratory system. And given the fact that, SARS-CoV-2, like coronavirus 1, is a respiratory virus, rapidly expelling air from your respiratory system very effectively expels those viral particles. But, it's only because those are some of the most effective ways to expel air. Yeah, yelling, that's doing a similar thing. That's very rapidly expelling air from your lungs through, your lower and upper, well, most importantly, your upper respiratory system. And so, yeah, and actually on the YouTube, I talked about this paper that came out from MIT that showed really how far a sneeze or a cough actually travels. And it's remarkable. So youtube.com/anthropoid, or you can just search for anthropoid Ian. You ain't no scientist. Well, I just finished my PhD in neuroscience. You can, listen, I think you're right to be skeptical of anybody who says that they're a scientist or a doctor on the internet. Like, very healthy response. And, if you come away by, always doing that about, people you've never seen before claiming that they're a scientist and a doctor, I'll be happy about that. But I would invite you to search my name, Ian McLaughlin. You can go to my Twitter profile, go to my website. You can see, where I got my PhD and in neuroscience at the University of Pennsylvania, by the way. And you can see my peer-reviewed papers. Do you know any more scientists on Perry, not just brain scientists? Yes. One of my friends is a cosmologist, so a physicist of the universe, named Deanna Hooper. Her handle is DC Hooper 91. And she does something very similar to what I do. There are other scientists, though they don't necessarily exclusively focus on like science-related topics. Christian Zasse, spelled like Sass, like Ben Sass in the United States, Sasse, but it's pronounced Zasse. He is a photographer, but I mean that term doesn't do him justice. Like he is an avian photographer and videographer. He's an astrophotographer. He takes just some of the most beautiful images that you'll ever see on the internet. He's a Zasse Photo, Sasse Photo, one word. Check them out. Twitter me, baby. You ain't got no friends. He just tell you about an essay that had been written by him in the college. I'm not quite sure what you mean by that. Okay, are there any effective brain vitamins or supplements you would recommend? So the short answer is not really. And I know a lot of physicians will say that, but I am totally open to, I think the appropriate scientific response to any question is not outright skepticism and, pessimism regarding its potential viability. It is, optimistic skepticism. It's, hey, there might be something here. If you have enough evidence, if you prove your point, then I will have to evaluate your evidence and adjust my perspective accordingly. So, there have been a lot of different vitamins and minerals that have been evaluated for potential neurobiological benefits. Broadly speaking, the vast majority have never proven to be particularly effective. Even ones that, like most members of the biomedical community, appreciate it as, yeah, they may not be like super critical, but they're probably good for you, like the omega-3 fatty acids. That's my daughter, by the way. But it turns out that once big enough studies were done, it turned out that omega-3 fatty acids just are not as beneficial as we thought. They probably don't hurt you, but they're not, it's not worth, if you're on a limited budget like I am, it's not worth your money, probably. What's really worth your money is a competent diet, making sure you're not eating too many simple carbohydrates, sugar in other words, making sure, you have a competent ratio of carbohydrates and fats and proteins, and that you do it consistently, right? Not that like, hey, I ate broccoli one day of the week, so I did my brain health for the week. The way that your diet affects your nervous system is by what it's consistently composed of. There is one exception. I'll say two exceptions. The first is turmeric. So that is a spice that's used. It's most closely associated with like cuisine from India, and within it is a molecule called curcumin that seems to be beneficial. It may be beneficial for a bunch of different ailments, but some evidence suggests that it might be beneficial to stave off the onset of dementia. So that's one. It's actually literally being evaluated for that potential application. The second is, and this is far more controversial, but I think that there's enough compelling evidence among the like longevity research community to make it worthy of acknowledgement, which is nicotinamide riboside, nicotinamide mononucleotide, and terastilbene, combined with terastilbene or resveratrol. To be clear, I am not saying that these are things that you need to go out and get. There's definitely not sufficient evidence to suggest that they're very, very effective, but there is some really interesting evidence regarding life extension and cognitive tests in preclinical models. He's not even replying to y'all. He's just reading from online somewhere. I'm reading you online. I'm not here to have him cure me. I'm interested. Adam Tweak. Are you asking what is the case of COVID-19? We can talk about that if you'd like. You need to be wary of these docs or brain scientists these days. Absolutely, Derek. I 100% agree with you. Actually, I can actually show you my diploma. I forgot I have it. Here. Now, the best thing for you to say right now is, oh, you just fabricated that, which, yeah, you have no way of verifying whether or not I just falsified that diploma. But, if you're interested, you can go on the internet and just literally type in my name, Ian McLaughlin, and brain, and I will come up. Is there not a prescription way to make front part of the brain less active? Well, there are. I mean, there are prescription ways. There are also recreational drugs that do that. But there's essentially no time when that is to your benefit. So the frontal regions of the brain are arguably the parts of the human brain that make humans humans, right? Like the prefrontal cortex, medial prefrontal cortex, these parts of the brain are like central to the types of behavior and decision-making that make humans more intelligent than other animals, including other primates. And that's because our frontal lobe is comparatively quite large. There are other parts of the brain that are obviously different as well, particularly the neocortex is really quite big in humans. But the prefrontal cortex is the machinery that enables us to, behave prudently, to, walk past an ice cream store and say, you know what, I'm not going to have ice cream. I know it's not good for me. I know in the short term it'll feel great, it'll be rewarding, but in the long term it might cause me to come to an early grave. Or another one is, you're at a bar, you know that you shouldn't have another beer, another shot, or whatever. Otherwise, you might hurt yourself, or you might behave recklessly. That your prefrontal cortex is that angel on your shoulder telling you not a good idea. Now, you asked if there are things that can inhibit the capacity of the frontal lobes to exert that influence, and alcohol actually does that. That is one of the things that alcohol does, which is part of the reason for why, in some people, not everybody, but in some people, they can become more aggressive. It's also part of the reason for why, it's disinhibiting. right? Because, this is a vast oversimplification, but one of the things that the frontal lobes is that it inhibits more primitive parts of the brain that are associated with urges and, sexual urges, aggressive urges, those types of things. And so when you're sort of inhibiting the signals coming out of the frontal lobes, that's what you're doing. You're allowing those more primitive parts of your brain to dominate. And then, hey, what's up, Kathy Nicole? Prescription drugs that do that, there's a bunch. But one of the most obvious ones are the benzodiazepines, Xanax, clonazepam, and barbiturates will do it too. Ask yourselves, why are his scopes always exactly the same BS? Well, you're right that certain topics come up consistently, but I think that it's because there are certain things that most people are interested in. Back in the day, I did have specific titles, but the issue was that, I have found it superior, more effective to enable the people who might come into this stream to guide the conversation for themselves, right? And if they have specific questions for which I can provide some kind of insights, that's, I think, just a more productive way to have a conversation. For example, if we were sitting next to each other in a bar or whatever, having a conversation, and I was just dictating the conversation to you, that wouldn't be the most interesting conversation to have, would it? Whoops. So that's why. But I'm glad to hear you've been in here before. Ask yourself why you keep coming in. Okay, we are connected to somebody with a nostalgic profile picture. Destiny, what's your name and where are you calling from?
I'm Kim Jong-un, calling from North Korea.
From North Korea. I kind of highly doubt that. Anyways, best of luck with the pandemic, buddy. Okay. Hola, Majo. ¿Qué tal? Can mushrooms help fix your brain chemistry? Oh, wait. Jeez. Okay. Derek D3 is a troll. Yeah, but he's not a very good troll. You know what I mean? Like, he's just sort of like aimlessly angry, which, like, all right, whatever, dude. But I mean, they're valid criticisms. He's right. I do always have the same title. All right. Sorry, we seem to not be able to connect the last caller. Feel free to call back in. Hey, from New Jersey. Hello. From your next door neighbor in Philly. Well, I guess not necessarily next door neighbor. Dude needs to get a life and go stroke his ego elsewhere. I assure you I'm not stroking my ego. But at this point, I'm getting worried about you. Like, what is it about your personality and your cognitive life, health, that inspires you to stay in here trying to tell other people what to do? What's the deal with you, buddy? Clean up your own backyard. All right, it looks like we are connected. What's your name and where are you calling from?
Hi, my name is Stephanie. I'm from New Jersey.
Oh, cool.
I actually did have one question.
Okay, shoot.
So, my boyfriend, I've been with him for about 2 years now. When he went to the hospital before that, for a year and a half, he's been having migraines. And before that year and a half, he's been having constant migraines. When he went to Capital Health Hopewell, New Jersey Hospital, they told him he had a brain infection. He keeps having constant migraines.
So they said it, what, like encephalitis? Did they say something like that? Or meningitis or something like that?
I think it was. It's in the emergency room papers, yes. They told him that if he takes Tylenol, he will be fine. It can cure it or something like that.
Wow. Well, I always need to caveat that, I'm not a physician, I'm a scientist. And so, I mean, if there's an infection in the brain, that can be very dire. That can be life-threatening. And so, if he's having if he's having recurring migraines are a thing, right? Like, they occur in people and they're not life-threatening. We don't understand all of the different causes of migraines. We know some of the potential causes, and there are some treatments that kind of hone in on one of the central causes. So, there are medications, like particularly novel medications out there that are available like for example, Aimovig is a novel medication. There are the triptan drugs that are, have been around for a long time. They're effective for some people. There's a novel medication that like just got approved that does similar things to Aimovig. There's even Botox, believe it or not, can be effective to treat some migraines. But if the physicians were confident that it was from an infection, and they must not have known that he's been having recurring migraines, because an infection that lasts that long, that would be very disastrous.
Yeah.
Yeah.
The thing is, they told him they had to take a biopsy from his skull, somewhere around his head. They had to take some type of biopsy from him, and then they had to do like an ultrasound before doing the biopsy to hit the right spot, because they said basically it is a brain infection. But I mean, he's had migraines, but it's not like constant. Like it's been going away. Like he hasn't had them anymore constantly after that.
Jeez. Well, I mean, that's good. Listen, I mean, if they've done a biopsy and that kind of stuff, and sure, even if not, like I would defer to them, of course. It seems like there must be something missing from this story, but what's that?
There has to be something else going on, because like for him to get still migraines, and then it doesn't like come constantly, it comes like here and there like normal migraines. That's still kind of weird, because after they said he has a brain infection, that just worries me, he's only 26 and he has a brain infection.
Yeah, I mean, I wish I had, an obvious, I wish I knew of an obvious, potential answer to this question. And, I'm not a physician. I mean, if they took a biopsy and they told him that there's an infection there, I mean, I would imagine that there would be some more specific medication to, manage that infection. Viral meningitis is life-threatening. But if they did a biopsy, I mean, yeah. Listen, I mean, Stephanie, I wish I had a better insight for you, but it might be worth. I don't know, what kind of position you guys are in, but it might be worth getting a second opinion and seeing if another physician might think, oh no, these are migraines. Why don't you try this medication and see if that might help?
Yeah. I'm gonna take him. I'm gonna make sure he goes to a specialist for the brain, to see if they can do something else than a biopsy. Because, like you said, you never know. It can be something else, because sometimes symptoms are related.
Yeah.
Like almost. They seem almost.
For sure. Yeah, absolutely. Yeah. Well, best of luck. I mean, let me know, by the way, if you guys do end up going to get a second opinion. It's really interesting. And by the way...
Sounds great. I'll definitely follow you on Periscope. Thank you.
Awesome. Thank you. And by the way, I love the mask that you're wearing. Very, very good move. Stephanie is wearing a face mask with a nice design on it, a little heart. It's very cute. I don't know. I didn't know pain drugs would get rid of an infection. So Tylenol is I mean, it's technically, used to manage pain, but it's actually not a painkiller in the same way as, opioids are, like hydrocodone or morphine. It's actually anti-inflammatory. So it would mitigate an immune system reaction that he may be having. But, I mean, if there's an infection in the brain, yeah, I just feel like I'm missing something. So Evan, I think we just connected. Is that your name, and where are you calling from?
I'm from Southern California. I was gonna ask you a question. I got 2 concussions, back to back, and what should I do with the issue? Because what I've been taking is like CBD oil.
Okay.
Because I'm starting to have like memory loss.
Okay.
I'm having issues with like not remembering things, and it's kind of crazy.
Well, Evan, I'm sorry to hear that. And I'm not a physician. The first thing you should do is go to the doctor, go to a physician, and get evaluated. They'll be able to do some neuroimaging and determine if there's any kind of damage to the brain. It's very, very critical to establish if that's happened. they will also be able to tell you, what kind of, how you should change your day-to-day life, depending upon the severity of the concussion, because like it's not obvious. It's like, I think a lot of folks approach a concussion the same way they approach like a sprained ankle or, physical therapy, which is, you basically go through a kind of physical training regimen and sort of lightly challenge the muscle or the bone or whatever, and then you progress as it heals. When it comes to concussions, that's really not the way it works. That's not how the brain works. And so, you want to make sure that first you have a good idea of how severe the concussion or two concussions were. And then second, you get some guidance as to, what should you be taking it easy, just sort of like not challenging your brain too much for a period of time. Or maybe they have some, cognitive tests that they would want to give you, particularly if you're experiencing memory loss. I mean, that's indicative of, a non-trivial injury. So, for sure, whether it's a free, clinic or, you have a primary care physician who can recommend or refer you to a neurologist, that's definitely what you should do.
Well, yeah, I have got an MRI, not once but twice done. And then I have had I think I hate to say it, but I think I have some CTE issues.
Okay. Yeah, I mean, yeah, this is the kind of thing. You said CTE, I assume chronic traumatic encephalopathy. Did a physician tell you that?
Yeah.
Wow, I'm sorry to hear it, man. That's the kind of thing where there are like specialist clinicians who have focused on how to manage over the long term people who, are confronting that kind of challenge. And it's not straightforward. There, by the way, there can also be medications to more specifically treat some of the symptoms of these traumatic brain injuries. Like I've seen some folks, report positive experiences using CBD for a variety of maladies, but I've never seen any evidence to suggest that it's particularly beneficial, for concussion or traumatic brain injury. Like, I've never seen any scientific evidence that that's the case. So I really wouldn't rely exclusively on that. I would, ask your physician, hey, what should I be doing day to day? And is there anything that you can help to, that you can prescribe me to treat this memory loss, or if you're having other symptoms like anxiety or, you're feeling aggressive impulses or things like that.
Yeah, I've noticed a change in my attitude. Like, I have not only the memory loss, but I've been like more aggressive, normally. And, I've been trying to change that cause I noticed it. And at the same time, I noticed that the CBD kind of helps. Like, I've just been taking that, and it calms me down.
Well, that's good. And I've never seen any evidence that it's, deleterious, but, it's the kind of thing where you want to be able to interact with a physician as early on as possible, so that you know the full extent of the injury. Obviously, you want to avoid subsequent head injuries, right? And it might be worth evaluating whether or not anxiety or aggression needs to be sort of managed, so that you don't find yourself in a situation where you behave in a way that you would never otherwise behave. So that's what I would suggest. But apart from that, I wish I had something better for you. But yeah, that's definitely the way forward, is to go talk to a physician about, what you should do day to day. Like, and, is there anything, would they recommend any other medications for you, just to make sure that you don't get into a position where you, just behave in a way you normally wouldn't. But listen, man, best of luck, and thanks for calling in. I really appreciate it.
All right.
Yeah, that's just the kind of thing where that's a significant, event in somebody's life. All right, you know what? I should probably call it a day there. So thank you all. Oh, wait, no. Not if Abyss is calling in. Last call for sure. But I could not miss this. Abyss, I'll not ask you where you're calling from, but what's on your mind?
Hey, Ian. How's quarantine life treating
you know, it's very surreal at this point, frankly. Like, my ability to gauge how many days have gone by is like completely obliterated. And yeah, but I mean, we're doing okay. Certainly other people are having it much more difficult than we are. But what about you?
Not bad. I mean, I'm kind of trying to get used to it, but it's kind of difficult. I would assume that, for those who have overt kind of social activity or something will be highly encumbered by this, unfortunate situation.
Yeah.
The reason why I'm calling is that I was wondering if you looked into some studies that actually cite the COVID-19 as sort of, or at least like the mortality due to the coronavirus to be some kind of a comorbidity as opposed to the virus itself being the cause of mortality itself.
Right.
Because there's a huge disparity between mortality rate here in the United States and also elsewhere in the world. So one of the things that was hypothesized, I guess, is that it has some kind of seasonality, or at least like it's dependent on environmental conditions or whatever.
Mm-hmm.
That was one of the things that was kind of proposed. But I was wondering if you looked into some studies. I mean, at this point, we barely know. I don't think anyone knows, what the true effects are, given that this is a novel kind of disease.
Yeah.
But yeah, I was just wondering what your insight is on that one.
Yeah. So I mean the sort of the vulnerability of people with pre-existing medical conditions was pretty early on established in China, and in particular among people who smoke. And there was a sort of, I think a lot of folks in biomedical science suspected that it was just because, the lungs are already being sort of chronically injured by cigarette smoke. And, another interesting statistical feature is that, men seem to be more vulnerable to both infection and severity of infection to COVID-19 than women. And so one of the early sort of presumptions was, culturally speaking, men in China tend to smoke much more than women, and a lot of people in China smoke cigarettes. And so that was part of the thought for like why it seemed to be more a higher mortality in China. And there are a bunch of other aspects to that, like they were only in the hospital, right? They weren't doing widespread testing in the way that like South Korea was, for example. Their strategy was more like clamping down, with quarantines. But in any case, so that came out, and then there was also comorbidities with like diabetes, obesity, and I think there was one more. Oh, like cardiovascular diseases, and so I haven't seen any good explanations for why, like, if there's just a broad, if any kind of biological malady renders you more vulnerable to like the immune system reaction in COVID-19. But like one of the ones that I found that I found about smoking in particular was it turns out that tobacco smoke causes an upregulation of the ACE2 receptor, the ACE2 receptor, that or I should say, enzyme. That protein is the one with which SARS-CoV-2, that the novel coronavirus, needs to interact to infect respiratory cells. And so when somebody's smoking, it's not just that the lungs are being damaged, but because you're literally like even more receptive to the virus. So there's that. In terms of one of the other interesting explanations that I've seen is like when in the case of somebody with diabetes or obesity, that there is this sort of chronic elevation of inflammatory signaling in those conditions, just general elevation of inflammation. And one of the the principal danger of catching COVID-19 is your immune system reaction. It is like a hyperactive cytokine storm, an overactive immune system reaction. And so if you're already at that sort of subtly elevated level, and then you have this reaction, it might be what's responsible for causing so much damage to the lungs so rapidly that you become incapable of driving oxygen from the air. That was one other explanation that seemed like, okay, that might be pretty viable. Just that's why maybe all of these different other pre-existing medical conditions statistically correlate with severe reactions to COVID-19. But apart from that smoking ACE2 connection, I haven't seen any like specific mechanistic explanations. But have you seen any?
No, not really. I mean, that's why I wanted to ask you about it.
Yeah.
Yeah.
Yeah, well, yeah, that's all I've seen. I mean, I don't know. I mean, it's new. The nice thing about how basically the entire scientific community is responding is that like a lot of journals that are typically behind a very high paywall are releasing their paywall for this kind of research, and a lot of people are making use of bioRxiv, medRxiv, these open source pre-peer review, pre-print indexes. And so, I would imagine that there will be a lot of interesting research that comes out. Like some of the coolest stuff that I've seen also is explaining why it is that SARS-CoV-2 seems to be able to infect both the upper and lower respiratory system, which makes it far better at spreading, far easier to spread, and far more dangerous. Right? Because generally speaking, lower respiratory infections tend to be more severe, but tend to be harder to spread, and vice versa for the upper respiratory, where it's much easier to spread, but they don't usually endanger somebody's life. This seems to be able to do both, which is part of the reason for why it spread so widely. And there's some interesting enzymatic. Ed Yong has an article, two articles in The Atlantic, I think, are some of the best that kind of encapsulate, no pun intended, like these findings. But yeah, I mean, I'm keeping my eyes out for something a little bit more mechanistic, because I would imagine there has to be something there. And like just the way this virus has evolved, the unique features, like have you seen the size of the genome of SARS-CoV-2? It's like,
I know it's really small. I mean, considering that level of that virus that with very limited amount of RNA can cause such devastation.
So you're like, yeah, it's small, but like relative to other RNA viruses, it's like 30 kilobases long. So like relative to other viruses that are comparable, it has a ton of genes. Like, not a lot. No virus has a lot of genes, right? But relative to other comparable ones, it actually has a lot of genetic activity, and it as a result, it's very versatile in its ability to adapt to different cell, intracellular, components that are available, and then it's also able to, be essentially expressed under a wider array of expression machinery. It's a really interesting and cool virus. But of course, you're right. It's not like it has a very, very small genome compared to like us or compared to like bacteria and stuff. Yeah. So it's something I'm keeping my eyes on, and I'm sure we're going to learn a lot about like how this evolution happened so rapidly. Like, yeah, and like, well, so in any case, yeah. All right. Was there anything else on your mind of this?
Right. I was wondering if you can just share something like how this would kind of, I mean, this recent pandemic about, virus being the cause of all this would assuage kind of the public mentality when it comes to, bacteria, which are sort of like, I mean, there are some bacterial infections which are drug resistant, right? And one of the things that was proposed was the bacteriophage treatment. So I was wondering how public opinion would actually change, given that we kind of recently encountered this kind of pandemic.
Yeah, I mean, it's definitely an interesting state of affairs. I mean, the United States has never responded to a biological threat like this ever. I don't think any country really has, and particularly not a country with the sort of the biomedical resources available to us. Putting aside the sort of lethargic response, the tardy response by the government, we are fortunate to live in a country with a ton of biomedical resources in some of the, particularly in the private sector, but also in the public sector. And so, like for example, and I'm sure you're already aware of this, but Dr. Peter Hotez, who is the head of tropical diseases at Baylor College of Medicine, where I used to work, actually an ex-girlfriend of mine got her PhD in his lab. they were developing a vaccine for after the SARS outbreak. But SARS, as we know now, didn't infect nearly as many people as this novel coronavirus, didn't kill as many people. And so, but what happened was after the outbreak, sort of petered out, people lost their interest in a vaccine. And part of and so as a result, the funding for that project didn't pan out. And so we could have had a vaccine that might have very well have been effective for this virus. And so the other problem is that there's this misconception that vaccines are profitable, right? Because, sort of intuitively it would make sense. Oh my God, look how many people would consume a vaccine. How could you not make money off of it? But they're actually not profit generating. And so, to speak to your topic, right? We do as a society need to appreciate that, these types of biological threats are going to occur predictably. It seems like every 10 years or so we get a coronavirus outbreak. SARS in the early 2000s, MERS in the 2010s, and then now SARS-CoV-2 or coronavirus 2. And so probably in about 10 years we'll have another one. Particularly, given that bats, there are so many different kinds of bats. I think 1 out of every 4 mammals on Earth is a bat, and our immune systems are actually quite similar to bats. And so, we as a society need to decide, okay, we're just investing in this. We don't expect it to generate profit. The profit that it's going to generate is preventing the, fatalities among the people that we love. And also, if you're, more pragmatically, let's say, less empathetically, it'll prevent us from having to endure unprecedented economic hardships, unemployment at numbers that we've never seen before in the United States. And, all we have to do is invest a tiny fraction of the money that we're now, confronting the loss into preparing ourselves, and so we don't have to rely on the private sector. We don't have to rely on convincing the private sector to generate these therapeutics. And then for, antibiotic resistant bacteria, like you brought up, that is sort of a looming threat that we've known about for a long time now, years and years. The short story for everybody that's unfamiliar is that when you get a bacterial infection, oftentimes you might actually be prescribed a Z-Pak, azithromycin, which is actually one of the components of the most widely available treatment for COVID-19, which is a combination of azithromycin and hydroxychloroquine. So azithromycin is an antibiotic. And so what happens is when you're treated with an antibiotic to treat a bacterial infection, there's a reason that you're told, make sure you take this antibiotic for the entire duration of the time I'm telling you. It's like 7 days or give or take a few days. There's a reason for that. And that is because antibiotics will kill the bacteria that are colonizing your body. But what can happen is that if you kill just enough of the bacteria to minimize the symptoms that you're experiencing from the presence of the bacteria, but they're still available there, they're still living there, they will evolve. It's essentially like natural selection occurring in your body. And what happens is that now only the bacteria that happen to just randomly evolve to be resistant to that antibiotic mechanism, they will persist. They will continue, inhabiting your body, and then you are vulnerable to spreading, or you have a propensity to spread it, and then you get something like, antibiotic-resistant superbacteria. And so we know this is coming. It's not an issue of if, it's an issue of when. And so what we need to do right now is recognize, just like this, novel coronavirus, COVID-19 threat that's, shaking the foundations of our country. Had we invested a little bit early, we would have been able to prevent this from happening. Same thing with antibiotic-resistant bacteria. If we invest now, well, not right now, we have other priorities right now, but after that, it's in all of our best interest. If there is any reason to have a country, mutual support to defending ourselves from things like this is certainly among them. We should invest now in novel treatments for bacterial infections, because if not, we're going to be dealing with a similar type of epidemic of, a bacterium for which we have no treatment. Was that sort of what was on your mind?
Right. I mean, yeah. So not to take up so much your time, but that's pretty much what I had in mind. You can answer the rest. I'll have to take care. I'm gonna have to leave now.
Okay, yeah, good for you, man.
Yeah.
Hopefully I will too. Hopefully the baby will too. Well, listen, it was great to hear from you. Abyss, everybody. A friend of mine now for several years. When Darwin and economics meet. Yeah, kind of. Can I call in? I have questions about brain health. You can, Irene, but if you have real concerns about your mental health, you should talk to a physician, right? I'm a scientist. I'm happy to try and elucidate things to the best of my ability, but if you are confronting mental health concerns, you should really talk to a physician. Saucy Mona Lisa, bye Abyss. Yeah. Saucy Mona Lisa knows Abyss. The real heads know. All right. Closed borders. So Kenopleo says closed borders. So, just speaking purely from the perspective of like biomedical science, not like immigration policy and that kind of stuff, closing borders was a reasonable idea. But the problem is that kind of, closing borders is actually not nearly as effective as you would think. And if you only do that, humans are crafty creatures, right? We solve problems like that. It's very easy to get around those borders, particularly if you have resources. And so just closing borders was never going to be enough, given how widespread the virus had already become. And so, what's even better is to invest in, more targeted and effective treatments for COVID-19. All right, everybody, I should call it a day there. I have a YouTube channel, youtube.com/anthropoid. I talked about how far a sneeze really travels, using actual science to gauge that. I also talked about the occurrence, interestingly, of some neurological symptoms, potentially among a minority of patients of COVID-19. youtube.com/anthropoid, or search anthropoid brain in YouTube, and you can check that out. I talked about other things that didn't have to do with the coronavirus as well. Dreams, exercise and dementia, stuff like that, before we all have been taken hostage by this outbreak, by this pandemic. I have a podcast called Wired to be Weird to talk about other topics in depth. Dreams, what is déjà vu, stuff like that. Wired to be Weird on iTunes and Stitcher. I assure you I will be updating that in the not too distant future. And I have a Patreon, and I know in these times things can be difficult, but if you are in a position to provide any support, I would appreciate it. It's patreon.com/anthropoid, and I assure you the first thing that I would acquire once I get enough funds is a new mic stand, because this thing is literally broken. It's just sort of like hanging in front of my face. So other than that, hopefully I'll see you at some point this week, but if I don't, I'll see you same time, same place next Sunday. The baby says goodbye, and so do I. See you guys. All right, YouTube, thank you so much for watching. I really appreciate it. And hope you have a great week. For the foreseeable, I'm keeping my eyes out for like interesting stories that have to do with COVID-19, not just sort of like general, stuff that you could get from other sources. And so hopefully I'll be returning to more just like actual neuroscience content, my favorite kind of content. But otherwise, if something cool comes out, I'll discuss that. But otherwise, yeah, have a great week. Thanks for watching. See you guys.